Oh, thanks for the opportunity to tell you something about transforming the weight measurements data of my beehives. During this presentation, I will give you first a brief introduction of myself and also the reason why I started with this analysis in the first place. I will show you some examples of the possible weight analysis that I did. And at the end of the presentation, I will also explain something about the tools which I've been using to transform the data in a suitable format. Well, I'm Eddy van der Geest and currently have about 5 beehives. One didn't survive the winter, so I started with 6, now I have 5. And 2 are equipped with a bee base. As a beekeeper, I try to not to interfere with my bees as little as possible. So I hope to timely recognize issues when there are issues from the outside by observing the behavior of the bees. The measurement of data coming from the bee bases offers an opportunity to extend these observations. And that's also why I started with the analysis of the weight. A former colleague of mine always asked the same question. So Eddy, how are the bees doing? Answer this simple question can be very difficult because what's the answer he's interested in? Are they happy, friendly, need any help, or survive next winter? When you add measurements, it might become easier to get an objective data to answer these types of questions. But then you have to also define how you interpret and compare the data that you collected. And also with what kind of reference source are you comparing the data? Before you start measurements and adding bee bases to your hive, you should first think of the real question that you have and that you want to be answered with this bee bases. A pitfall which often happens is that measurements and collecting data becomes the primary goal, instead of answering the question that you're really interested in. In 2020, I had the opportunity to participate in a pilot project. The primary aim was to gain experience and to identify which type of techniques and measurements could contribute to understanding the relation between honeybees and solitary bees. 8 hives had been equipped with bee bases, and this gave me the opportunity to perform some data analysis on these 8 bee bases. I expect that most of you are familiar with the Beep app and with the graphs which are available. Although the current version of the Beep app has some more functionalities, the graphs still show the temperature, the weight, and the sounds. The bee bases collect and send their data every 15 minutes. This data can be extracted as a comma-separated file for further analysis. The data analysis techniques on this type of data is called time series analysis. And usually, in this type of analysis, you try to identify and distinguish between the regular and the irregular patterns and trends. As an example, you can perform a time series analysis on your electricity usage at home. In such analysis, you will find a daily, a weekly, and also a seasonal pattern. When you wake up, when you put on the lights, these are all reflected in this in energy usage. For bees, every day is a working day, and it's not expected that you will find differences between a normal day, a working week, and a Saturday or Sundays. Although many beekeepers might do their inspections during the weekend, which might be reflected in the data. For bees, an important pattern is, of course, the seasonal pattern during winter, spring, the honey season, and also after the longest day. If you look at the graphs for the weight, you notice that there is a regular daily pattern, starting high in the morning when the weight drops and gradually increases during the day. This is what a beekeeper will recognize when the flying bees leave the hive and return with food and water. During the evening and the night, the weight continues to gain, although there are no longer flying bees for collecting food and water, but still the weight increases. In of this presentation, I will focus on the measurements of the weight and not go into detail with temperature or the sound. My My initial idea was to compare the minimum and the maximum weight for each calendar day. Before doing this, I realized I needed to clean up the data for anomalies because the weighing data included some errors. Each time when you open the hive or for an inspection or change anything to the weight of the hive, the weight of the hive is influenced, of course. And these changes should be eliminated. Also, one other thing is that my cat likes to sit on the top of the hive, so that also has an influence on the weight. During the first analysis, I noticed that the maximum weight of the beehive can occur during the early morning or in the evening the day before. Comparing calendar days resulted in unexpected results. Then I realized that the minimum weight during a calendar day of a beehive was a better way to determine when a bee day started and ended. And the maximum weight between these two minimum weights resulted in a proper comparison. For my beehive, I was now able to present the minimum and maximum values. In the graph on the right, I used the day as a number instead of the day and month. Using the same algorithm, I could now also compare the data of the other 7 beep bases and compare the maximum weights between the 7. The graph shows that the beehives all have a very different maximum weights, and the development over time is very different. An issue which occurs often with IoT devices is that sometimes no data is received and no maximum weight can be calculated. I decided not to use a linear regression to fill the gaps, but just show the gaps as they occur. To make the maximum weight measurements comparable between beep bases, I used the cumulative daily variance. This way, the physical weight of the beehive, the hive, doesn't influence the comparison. This graph shows that the red and the orange hive gains weight early in the season, followed by the blue hive with a very steep weight gain around day 166, that's in mid-June. The yellow hive shows a steady increase quite late in the season, but this hive was only 30 kilograms in July, and I expect this was a newly started colony. The data analysis has not been checked in detail with the involved beekeepers to understand why certain beehives gained weight early in the season. It would be interesting to know how well these colonies performed in collecting honey, their health, and if they survived the next winter. Also, with only 8 bee bases, the variations between the various bee colonies was quite large. A larger data set with more beehives, with more hives, would enable to make this type of analysis more robust. The tool that I have been using for this analysis is a free and open source tool, which is called KNIME. It has an easy graphical user interface, and it's easy to document all the steps of the analysis and also the data extraction, the transformation, and the load procedures. A similar analysis you can also perform using R or Python, but the data discovery I find more easy to do in the first instance with KNIME. So, how are the bees doing? The simple answer to this question would be ask our cat. But for a better understanding of how bees are doing, I think we need to develop the weight analysis in more detail. By comparing the weight of beehives in the same region, also compare the bee population with a similar population with the same kind of background and an age of the queen, and also analyze the data for each bee season. And maybe you can also compare it with prior years with the correction of early and late spring. So that was the presentation I want to share with you.